Good day, students. I welcome you to study session 9 of NSC 206, which will discuss isomerism. In the study of organic chemistry, we come across many cases when two or more compounds are made of equal number of like atoms. A molecular formula does not tell the nature of organic compound. Sometimes, several organic compounds may have same molecular formula. These compounds possess the same molecular formula but differ from each other in physical or chemical properties, and these are called isomers, and the phenomenon is termed isomerism. At the end of this study session, you should be able to explain isomerism. You should be able to discuss chirality and stereogenic centers. You should be able to explain enantiometers, diastereomers, and mesocompounds. What is isomerism? Isomerism is a phenomenon whereby certain compounds with the same molecular formula exist in different forms owing to their different organization of atoms. Since isomers have the same molecular formula, the difference in their properties must be due to the different modes of the combination or arrangement of atoms within the molecules. Broadly speaking, there are two types of isomerism. We have the structural isomerism and we have the stereoisomerism, which are further classified into subclasses as you can see on the picture on your screen. Structural isomerism. When the isomerism is simply due to difference in the arrangement of atoms within the molecule without any reference to space, the phenomenon is termed structural isomerism. It can be chain or nuclear isomerism, it can be positional isomerism, it can be functional isomerism, metamerism, and tautomerism. Chain isomerism arises from the difference in the structure of carbon chain, which forms the nucleus of the molecule. Positional isomerism is the one in which the compounds possessing same molecular formula differ in their properties due to difference in the position of either the functional group or the multiple bond or the branch chain attached to the main carbon chain. When any two compounds have the same molecular formula but possesses different functional groups, they are called functional isomers. Metamerism is due to the unequal distribution of carbon atoms on either side of the functional group in the molecule of compounds belonging to the same class. And tautomerism is simply the type of isomerism in which two functional isomers exist together in equilibrium. What is stereoisomerism? Stereoisomers: same molecular formula, same connectivity, same constitutional isomer, different spatial orientation of the bonds. When isomerism is caused by different arrangement of atoms or groups in space, the phenomenon is called stereoisomerism. The stereoisomers have the same structural formulas but differ in the spatial arrangement of atoms or groups in the molecule. Stereoisomerism is of two types. We have the geometrical or the optical isomerism. Isomers which possess the same molecular but structural formula but differ in arrangement of atoms or groups in space around the double bonds are known as geometrical isomers. And if a substance is optically active, it is non-superimposable on its mirror image. Chirality and stereogenic centers. The word chirality refers to the property of handiness. Your right and left hands are very similar, yet they are not identical. They are related to each other as mirror images, and as such they cannot be superimposed on top of each other. Molecules can also be chiral if they contain one or more chiral centers. Enantiomers, diastereomers, and mesocompounds. Stereoisomers which are related to each other as mirror images are called enantiomers. Enantiomers can contain any number of stereogenic centers as long as each center is the exact mirror image of the corresponding center in the other molecule. Diastereomers, these are stereoisomers which are not enantiomers. And a mesocompound contains at least two stereogenic centers, yet the molecule itself is not chiral. This is because mesocompounds contain an internal plane of symmetry. The molecule can be split by an imaginary mirror so that all atoms on one side of the mirror are the exact reflection of the atoms on the other side of the mirror. I think with this lecture you have been able to understand isomers. Thanks for listening. Have a good day.